Question B3, this question is about radioactive decay. So we have iodine 124 is an unstable radioisotope with proton number 53. It undergoes beta decay to form an isotope of tellurium Te. State the reaction for the decay of the I-124 nuclide. So we get iodine 124, and this is 53, and it's going to go to tellurium Te. Now we know it's going to, it says it goes beta plus decay. So in beta plus decay, what happens is that you get a proton changes into a neutron plus a positive electron, an E plus. So in actual fact, your proton number, your atomic number, actually decreases. So this will go to 52. But because you've got the same number of nucleons, you just have a proton change into a neutron, you've got the same number of nucleons, so this is going to remain the same. So we're going to have that. We write this as 1, 0 over here because this is this has got, we take it 0, it's 0 nucleons, and plus there is a neutrino that is also given off like that. So that would be your reaction there. Then it says the graph below shows the activity of a sample of iodine 120 as iodine 124 changes with time. So you have your activity here, it's times 10 to the 7 Becquerel, and this is in days. So this is the number of radioactive events, radioactive nuclei decaying per day. So I'm just going to read the questions. The questions are over on the page, but we need to use this graph, so I'll keep the graph up here. It says, state the half-life of iodine 124. Well, we're starting at 16, and obviously our activity goes down to half, is at 8. So this over here, this point over here would be our half-life, so it's going to be 4 days. So the half-life for question 1, the half-life would be 4 days for that. That's 1. Then it says calculate the activity of the sample at 21 days. Okay, I'm just going to clear this so that we can see. So we want to calculate the activity at 21 days. We know that our half-life is 4 days. So I can straight away use this formula over here to work out the decay constant. So I can say that lambda is equal to ln of 2 divided by the half-life, which is 4 days. So it's ln over 4. And I can calculate that using my calculator. And in doing that, I get 0.173 per day. All right, so that would be my lambda, my decay constant. Now, I am wanting to work out the activity at 21 days. So I'm going to use this formula over here, that A is equal to lambda in 0 e to the minus lambda t. But this, as I've said before, this lambda in 0, this is the activity at the start. So that's equal to A is equal to A0 e to the minus lambda t. So it's going to be A is equal to A0 is my activity at 0 time. So that would be 16. At 16. E to the minus lambda, so that's 0.173 times my time, which is 21 days, so times 21. And we'll do that on our calculator, and we should get something like 4.2 times 10 to the 6 Becquerel. Now, there's one thing that I just forgot to put in here, which is very important. This is 16 times 10 to the 7. I mustn't forget, that's 16 times 10 to the 7. So that's why we get this times 10 to the 6 factor here. And then lastly, they say, well, there's the third question. A sample of an unknown radioisotope has a half-life twice that of iodine-124. So iodine-124 had a half-life of 4. This must therefore have a half-life of 8. So an initial activity the same as the iodine-124. On the axis opposite, this one over here, draw a graph to show how the activity of the sample would change with time. So with this one now, every 8 days would be half. So after 8 days, we would have 8. So I hope I'm going to get this to be somewhere around there. My board isn't synchronized very well. So after 8 days, it would be 8. After 16 days, it would be 4. So I'd be somewhere around over there. And my shape of my graph would look, sorry, it should be a nice curve there, would be like that. Let me just redo that. So 8 days it would be 8, and 16 days would be 4, and so I would get a graph like that. And then and we got to label this X. Then it says a second isotope of iodine-124 has a half-life, has half the initial activity. So we're starting here at 8. On the axis opposite, draw a graph to show how the activity of this sample would change with time. So now we saw with iodine 124, so it's got a half-life of 4 days. So in 4 days it would be 4, half of 8, and after another 4 days it would be 2, and after another 4 days it would be 1, somewhere around over there, and after another half-life it would be half there, it would be something like that. So you'd get, sorry, that should be below there. So you should get a graph something like this, forming like that, and that would be Y.